Welcome to Module 6, Lesson 6. In this lesson, we're going to focus on using partial quotients to divide multi-digit numbers by one-digit numbers. So we've been seeing something similar with partial quotient in using area models. We're just going to look at this a little bit different in this lesson. Right, so to review, we're going to use an area model to start. Number 1, an airplane has 165 seats. There are 5 seats in each row. How many rows of seats are there? Draw an area model to represent 165 divided by 5. Let's pop down to letter A first. How can we break up 165 into smaller parts that are multiples of 5? Remember, I'm not just going to think about this as expanded form. All right, so I'm looking for big multiples of 5 here. Right away, I see 100. I know that 100 is a multiple of 5. So now I'm left with 65. I can break up 65 into 50 and 15, both of which are multiples of 5 that are easy for me to divide. All right, so now let's go ahead and draw our area model. We don't necessarily need to focus on making sure it's exact because we don't know how many columns there are yet. Okay, so we know that we have 5 rows, 2, 3, 4, 5, and we have 3 sections because we have 3 partial dividends that we are going to divide. Okay, our divisor of 5, we put each of those dividends inside. And now we'll place those partial quotients at the top. So 100 divided by 5, it's the same as thinking of 10 tens divided by 5, which would be 2 tens or 20. 50 divided by 5 is 10, and 15 divided by 5 is 3. So in order to find our quotient, we would add up our partial quotients. Find 33. Okay, let's go ahead and answer the rest of the questions now. How can you divide each smaller part of the dividend to find a smaller part of the whole number quotient? What this question is asking us is basically, what did we do here? What were the equations that we used, right? Think back to when we were working on distributive property. What were the equations we used when we divided the smaller parts of the dividends to find the smaller parts of the whole number quotients, right? We found our partial quotients. The first one we did was 100 divided by 5, and that equaled 20. That was our partial quotient 1. 50 divided by 5, which equals 10, partial quotient 2, and 15 divided by 5, which was equal to 3, which was our third partial quotient. It's really asking us just to rewrite our equations. Letter C, each smaller part of the whole number quotient is called a partial quotient. How can we use these partial quotients to find it? Well, what do we need to do with those partial quotients? We already did it up at the top. How do we find it? We add our partial quotients together. So when we add 20, 10, and 3, we find that there are 33 rows of seats. Right, so now we're going to show partial quotients in a different way. This looks a lot more like standard algorithm when we're doing division. So we'll use partial quotients to divide. Letter A, find a multiple of the divisor that is less than or equal to the dividend. So we see the dividend is 862. We're trying to think of what is a multiple of 7 that's close to this number. It gave us our hint right over here. Okay? What's close to 862 that's a multiple of 7? 700 is. Now, to the side, we would write this equation. 7 times 100. 100 is our partial quotient over here. Okay, we're left with 162. We have to keep going. We have to keep finding these partial quotients, or partial dividends here. Again, it gave us our partial quotient of 20. 7 times 20 is 140. We're looking for that close multiple. 162 minus 140 is 22. When we see 22, what is our closest multiple? Well, 21 is a really close multiple of 7. 3 is our partial quotient. All right, in order to find our whole number quotient, we add our partial quotients. So 123. So our answer is 862 divided by 7 is 123 with a remainder of 1. Right. Go ahead and complete check understanding. Press play when you're ready to check your work. Right, so it asked you to kind of show it 2 different ways. We found the answer was 212. We used our area model and we used our partial quotients. Now I want to show you there's another way we could have done this with partial quotient, which you might have seen. So we have 848, we're still dividing by 4. Okay, I found my first multiple was 800. Now some of you might have seen this. We had 48 remaining. 48 is a multiple of 4. So I could have used 48 here and said this was equal to 4 times 12. Then I would have seen still the same answer. 212 would still be my quotient. So that's just in case you got confused by how many boxes were here. If you saw right away that 48 was a multiple of 4.